Hello and welcome to this video. In this video, we will look at &str functions, but these functions are also applicable to string type because string type inherit all the methods of &str types. The first function is eq underscore ignore underscore ski underscore case. What it does is it is invoked on a string or &str, which I'll simply call string slice. It invokes on a string and then it compares with the string in the argument. So Ferris, when f is capital and others are in small, is equal to Ferris when all capital because ASCII case is ignored. Note that the Unicode case does not matter. It only ignores ASCII case. So it cannot match the Unicode case. It only ignores ASCII case. So here, if it is O with umlaut or umlaut, I don't know the exact pronunciation. It is pronounced as if it's a long O. So we'll pronounce it as Ferros, okay, with a stress on O. So if this O is a small o with umlaut and here it is with capital O, then we cannot ignore this case. So this won't match. Let's see by running this one. So it succeeds. We comment this out. The second is we can convert a string into bytes. So the method which you need to invoke is called as bytes, and then you can compare it with plain bytes. Yep, succeeds. The other would be as mutable bytes. Okay, it also converts into byte, but as mutable bytes. Next one is a bit weird. The characters have not come properly. These are Unicode characters. The current font does not have ligatures for them, but these are Unicode characters. So we have a string with these Unicode characters and we take them as mutable bytes, and then we assign them such Unicode code points that it is as same as this string. Okay, then we run this. There is no if we change the font, maybe this will render, but then that will mess other images. So maybe you can ignore this example. Just understand that you can take you can invoke the as bytes underscore mute function, and then you can overwrite those bytes as if they are part of a vector or array. So we comment this out. Okay, printing this one. This as ptr, we will skip this. So now we convert this into bytes. Bytes will give us an iterator, okay, and we can invoke the next function on the iterator to get the byte. The bors will give us each byte at a time. So first byte is B, second is O, third is R, and next is S. After S, the iterator is exhausted and then it will return none. So I'm not presenting all the functions, only the functions which will be very useful for us. For an exhaustive list, you should consult the Rust documentation. So split white space will split a string on white space. Okay. And it will return an iterator and it will give us strings. It will give us strings and we can compare those strings with the words in the string. And once it is exhausted, then it will return none. Now, it not only splits plain white space, that is the space character, it will also split the other space characters like this Unicode space character \n\t. Okay, see this? Yeah. So Mary had a little lamb will be the words returned by the iterator. Now, if we look at this, then it will return the ASCII white space. It will not split based on Unicode white space. So we have removed the Unicode character from this. It will again return as Mary had a little lamb, followed by none. Now we can split a text into lines. So the line ending characters are \n on Linux and \n on Windows. So here we will have foo bar, and there are two line ending characters. One \n will be there, and just followed by \n. That will be an empty string. And if the last is \n, then it will not give us an empty string after this. So this will return foo bar empty string badge, followed by none. So we look at this, and if we remove the last rn, only then also it will return us the same thing. So suppose we have a word called goodbye, then char indices will return an iterator. Okay, if you look at this, it returns an iterator. Char indices returns an iterator, and we can invoke count on the iterator. Okay, so it returns the length of the count of the characters in the goodbye string, and that would be 7. Similarly, we can take mutable char indices here, and we assign it to the char indices, that is the iterator, and we can invoke the iterator one by one, and then at those indices it will return a tuple and a character, a tuple of byte position and character. So 0 position will contain G, 1 will contain O, 2 will also contain O, and so on. So the string is exhausted, it will return none. Sometimes you will be surprised by what is returned. Okay, so at 0 it is Y. Okay, for example, this is a Unicode character. Let me zoom it a bit. This is a Unicode character. It will return Y followed by a Unicode. 0th position, the char index will not give you the Unicode character. This is something you have to be careful about when you are dealing with Unicode characters. So furthermore, you can see that E occupies the 3rd position, okay, and S occupies the 4th position. Expanding on to the previous example, we use this char Y with half a moon over it, and we invoke chars on this. And this iterator will give us two different characters, Y and Unicode, and then it will return none. So this is something I'll repeat, that when you're dealing with Unicode characters, be careful when you invoke certain functions. Now our next thing is finding substrings. So string bananas contain nana, and it does not contain apples. Bananas contains anas, and it also ends with nana. So there are two functions described here, contains and ends with. So bananas ends with anas, and bananas does not end with nana. Sorry about the confusion. So you see these two functions. So if you want to find a substring, you test it, then it will be useful. As you can see, it returns a bool which will be either true or false, and ends with will also return a boolean. So we move on to some other function. It is called find. So find will take a pattern, okay, It can be a regular expression also, possibly. I don't remember. Uh, it's not here. We will deal with regular expressions when we go into regular expression chapter. So L, it will look and find at index 1. It will return the first index also. The acute E, it will find at leopard and return that index. Okay. So this is at position 0, this is at position 14, and pard is at position 17. So now we look at this. So what we are doing is we find a white space character. Okay, we try to find a white space character. This is the pattern we have passed, which is at position 5 after LOWE, and a lowercase character is found at position 1, which is the O with umlaut, and then we can pass a function here, a closure here, which specifies that it can be a white space or lowercase, which is found at position 1. Okay, I don't know how this Unicode is constituted, so we'll have to go inside that to figure out this out. But I think that it won't match the white space, it will match the lowercase. So O umlaut will be the lowercase, which is at position 1. And similarly, we can pass it another closure where it will say that it should be less than O and greater than A. So such a character is E, which is found at position 4. So you can specify complex expressions in this closure, and it will work very nicely for complicated cases. Now we use the get function. The get gets a slice from any string. So here we have hello. We have specified the slice 0 to 2. Note that it is half close, half open, closed on left side and open on right side. So it will take two characters, that is at position 0 and 1, and H and E will be returned. Again, the same example with a Unicode one. Sadly, it won't print on this font. So, like, copied from the Rust documentation, so it won't print because it's a graphical font. Okay, there is more example here on this. So, for example, if this is not a Unicode boundary, then it will return none. So, for all these cases, all these slices, it will return none. So, the first slash takes from first character to the end. The second takes from the beginning to its character, and the third is out of bounds. So we have this character string hello, and we try to get 0 to 4, including 4, and that is sum, that is not none. But 42 is out of bounds for hello because there are only 5 characters. Then what we do is we get the mutable get a mutable string from 0 to 2, that is he, and then we map it, we dereference it, and then create a slice out of it that will be equal to he. Now we do an assertion hello with v, so it will match. We come to this in a bit, the block. So what the block does is it will get the slice from v, that is he. Now it maps each character of this s and makes it uppercase, and then creates another slice, so that will become he, and therefore the string will become capital HELLO. So I don't think I need to put this inside parentheses. This will work without parentheses also. move on to next. The other, I think we have seen this in previous video. Hello is an ASCII string. This is a non-ASCII string. So is ASCII execution will work accordingly. It will return a boolean. If the contents of the entire string is ASCII, then is ASCII will return true. Otherwise, it will return false. Now we test the char boundaries function. Okay. So if you see this, what it does is checks the index byte is the first byte in a UTF-8 code point sequence or the end of string. The start and end of the string when index is equal to self-len are considered to be boundaries. Returns fall if index is greater than self-len. So if you look at zero boundary, it is the beginning of a char boundary. Similarly for 6, because L is 1 character, O umlaut is 2, 3, 4, 5, 6. So 6 is a char boundary, and the length, that is the end of string, is also a char boundary. Now, if you look at position 2, that is not a char boundary. Okay. Third byte of this is not a char boundary. Okay. I think O will be more than 2 bytes. O will be more than 2 bytes. So you can confirm this for me, whether O is more than 2 bytes. Next function is empty, and that is simple, and its negation will give you not empty. So if the string is empty will return true. If it's not empty, is empty will return false. Length, I think we have seen in the earlier video, it just returns the string length. Remember that Unicode strings will have a longer length than the number of characters in them. So this F, I think we have seen this in the previous video also. This F is a fancy F, Unicode value. So the length will be 4, but char count will be 3. I think we have also seen string lowercase. So it will convert the convertible values, that is the ASCII characters, to lowercase. Next is match indices. So match indices, what it does is, if you look at the there's no documentation here. Okay, so I'll tell you what it does is, it will look for ABC inside this string and put the index and the string found in the vector. So ABC is at 3 places, so indexes and that thing is put. So we compare this with 0 ABC, 6 ABC, and 12. Similarly, 1 ABC, ABC2 will find ABC at 2 positions. ABA will be found at position 1 only. Okay, because it overlaps, it will be found 1. If you want to find it twice, what you can do is, first we see this, then I'll show you the other thing. So what we can do is, we can put another ABA here, and then it will be 314 4 comma not 4 3 ABC. Okay, ABA, it is not ABC. So now it finds, because both the ABAs do not overlap. Similarly, you have matches. This will simply give you a vector element of str, not the indices. And then you can pass patterns like char is numeric, or char is white space, that kind of thing, or char is lowercase. So those kind of things you can pass, and it will match with those. Let me show this. Now next function is parse. So there are 2 ways you can use this. One is that you do a parse and unwrap. In this case, you have to type annotate the variable and it will be automatically understood. Second way is to parse in a turbofish way. This is called turbofish way. So you supply the type here, left side annotation is not needed, and it will return an option enum, and this will be okay for. So after this, you have to extract the value out. So if you are sure about the value, you can use the unwrap. Otherwise, you should, if you're not sure that an integer is coming, you should parse it using the trebuchet way. So for example, if you're writing a console program and you're taking user input, then there might be a mistake in the input. So you should try the second way. Because first will cause panic if it can't parse. In this case, you can handle it. So we see this. Now, if parse fails, it will return you an error, which you can test with is error. Next is now we are trying to repeat. We are using a repeat function. First, we see that. So ABC, if it repeated 4 times, it becomes this. Now we are repeating this string usize max number of times. This is the 64-bit unsigned integer. So if you repeat this so many times, the string will be very large, and the max length of the string is usize max. So this will be 16 times that number. So it will be out of bounds and will cause a panic. You see that main panic. Now we see search and replace. So we have a search and replace. We search for old and replace with new. We search for is and replace with an. So both the is will be replaced. The is of this and is the word. Now, if the match is not found, then the entire string is returned. So in this case, Cookie Monster and Little Lamb will not be found in this is old, so it will return the entire string. So I'll stop here. With this, we come to an end of this video. We have not yet completely covered this str slice, string slice. In the next video, I'll try to complete most common functions required for string slices and string type. So stay tuned for the next video. Thanks a lot for watching.